In this video, we're going to demonstrate pointer to implementation, or Pimpl, and threading. So I've implemented Pimpl in the camera class. The camera and the camera Pimpl class have the same method declarations, here and here. Where they differ is in the method implementation and in the private data. So the camera has really just one private data member, which is a pointer to the camera implementation, and the implementation class has all the variables it needs to operate the camera. The camera class also has a forward declaration to the Pimpl class, which I'll talk about in a minute. So for this demo, I've included the camera class header in most of the CPP files. So let's see what happens if we make a change to the camera class by adding a new variable. So we'll just re-add this one. And we'll build with F7. And all of the classes are being rebuilt. So it's the total rebuild apocalypse. Not good. So now let's add a private variable to the Pimpl class. Just make a change there and we'll rebuild. And only two classes get rebuilt, the Pimpl class and the camera class. So we have saved some time in our development. Okay, let's move on to threading. So for this demo, I took an old AI project and created a thread for each enemy. Here we create the threads, right here, and a loop for each enemy, and then in this part we continually call the update function of the enemy for this thread, which controls its behavior. One thing you're going to need to watch out for as you increase the number of enemies is that you need to increase the sleep time here and here. Once you get to about 500 enemies, you'll need to start increasing the sleep time to avoid runtime errors. And at 1500 enemies, I found that a value of 10 milliseconds for both was required. So we add a critical section to the update function of our enemies. When we update the last position and last orientation of an enemy so that we don't get read and write access errors when the render function uses the last position and last orientation. Initially, I compared the unlocked frame rate of the original AI project with the threaded project and didn't find a significant difference. So instead, I checked the average time between calls to the enemy function update for both projects, and here's the results. As you can see, the threaded version, which is the red points, does 25 to 50% more calculations depending on the number of enemies spawned. One implication of this is that you can create more complicated enemies with threading and use the same amount of CPU time. Okay, so just one more thing to show you. So this is the unthreaded version, and in the enemy update I make a call to the system pause function after 100,000 calls to update, when I'm calculating the average time between update calls, and you can see it pauses the entire thing. Now if I run the threaded version, doing the same thing, make a call to system pause. Okay, so here's the system pause. It only paused one of the AIs, but the rest are running in the background. So that shows you that the threading is actually happening. Alright, I hope you enjoyed the video, and have a good day.